Okay, there we go. So, assuming everybody has Google Colab open or some other way of running Jupyter Notebook, you need to get the data in here first to run all the cells that we have. If you're doing it through Google Colab, what you have to do is go to this files icon. It'll take it a minute to connect, but you should see something called sample data. All you're going to do is drag the data itself, AirBnB open data, into that pane, just like this. It may take a second for it to upload, but it'll give you a warning if it's successful. It'll say this runtime's files will be deleted when this runtime is terminated. Basically what that means is that Google Colab will not remember your data. You would have to put it in every time that you open this notebook. And that's just for safety reasons, that Google's not trying to get a hold of all of your data that you're putting in there. In general, I would say that if you're working with, what's up? Okay. I would say in general, if you're working with sensitive data, a local Jupyter Notebook is better. But for this, because it's open data, we can use Google Colab without any issues. Right, so once you have that file in there, it should be AirBnB open data XLSX. We're going to get started with the actual cleaning process. So the reason why we do data cleaning is basically because data is often not suitable for analysis right away. You might have values that are way too far apart from the rest of the group, and that would affect your data. You might have the wrong data types, so you can't perform analysis properly with it. And there are a couple other issues that can arise with incorrect and not clean data. Give me 1 second and I'll close the door here just so I'm not bothering anybody. All right, there we go. And so pretty much the reason, again, why we clean data is so that it is ready for analysis. Because if we don't clean it, our analysis will be improper. This whole process that we're going to do right now is just a way to make sure that your analysis is valid, basically. So let's talk a little bit about the process itself. And starting with understanding what your data is and what questions you might want to ask of it. So if you don't know your data well enough, and if you don't know what you want to ask, you won't know how to clean it. And that can mean that you give columns the wrong data type. You could delete columns that you need for your analysis, or you can just make a file that is so unwieldy that nobody wants to work with it. So you have to understand your questions so you know what you actually need. And you need to know what your data represents so that you know what it should be. And so once we understand all that, we can get into actually cleaning the data. This data set, as implied by the name, is an Airbnb data set. It's from New York. And as we go through this process, we'll basically be looking at any column that can be used for data analysis purposes. So we don't have a direct research question. But if we were working on this for a company or for a personal project, we would want to define a clear question, right? So in general, the process that you want to take is to ensure that you have the proper data types, delete any duplicate data, filter the data down to what you actually need for your analysis, address any troublesome data that might exist, and that means stuff like outliers, and handle any missing data that you get. So The first thing we need to do, of course, is to actually get our data into Python, along with all the packages that we need to perform data cleaning. So what we're going to import are some pretty standard packages: pandas, numpy, and matplotlib. Pandas basically allows you to do basic data analysis and also load your data into Python. NumPy works a little bit more on the calculation side, and matplotlib does data visualization. So once you have this open, all you have to do is hit Shift, Enter, and that should run the cell. And if it runs successfully, you should see a green check mark next to that cell. So the first thing I want to talk about are the data types. And I'll show you an example here. The first thing we're going to do is load the data into a data frame, and then we're actually going to load all the data types that we have. So to create a data frame, we use the pandas function, the pandas library. We're going to do read Excel instead, because this is an Excel file and not a CSV. And I'll correct this at the end there. So again, you do need to XLSX, is that correct? Yes, okay. So yeah, you need to correct that CSV to Excel and then that CSV to XLSX for it to run correctly. But once you do that and you run the cell, it should give you a list of all the columns and their corresponding data types. It can take a minute to actually execute this, simply because it is a somewhat large data set, and you're also running it on Chrome, which takes up more memory, and that just makes things slower in general. And Jupyter notebooks are kind of slow in general. So we'll just give that a couple seconds, see what happens. In the meantime, let's talk about the data types themselves and what you can expect to see and what they mean. Pandas data frames will typically recognize a few different data types. There are integers, floats, objects, and dates. An integer is just a whole number, as you might expect. A float, that's a new terminology. Those are just numbers that have decimals. And an object is pretty much textual data. It doesn't necessarily have to be text, but it generally is. And what I mean by that is that this is basically just data that exists that isn't used or able to be used for any math calculations. And date is just storing the date type properly. And so whenever we look at the result of this dataframe.info, we will see a few different things. So we'll see a list of all of the columns that exist, for one. We'll see something called the non-null count, which we'll get into later, and also the data type. So here we see that ID has a data type of integer, which whenever we look at the data, it makes sense. They're all just listed numbers and they don't have a decimal point. Name is an object, meaning that it's text, basically, and that seems to make sense. Somebody's name is probably not a number. And there's some float types in here for latitude and longitude, which again makes sense. But as we go down, you might find some stuff that's a little bit concerning. But we'll get into that in just a second. So there were a few columns with some concerning data types. I'll go over some of this list, but not all of it, because we'll go through the cleaning process as we go forward. The year, price, and service fee were all listed as float types, if I remember correctly. So year, oh wait, what was the construction year? That's right. Yeah, construction year is a float, which doesn't make sense because years do not have decimal points. They're just strings of 4 numbers. There's no decimal. And there are a couple of things where the data type just does not make sense. And so what we want to do whenever we see that is first do this head function, which basically will show the first X number of rows in your data set. Here, I specified that I wanted to show 10 rows. But if I wanted to show 5, I could just leave that blank because 5 is the default. I could also show 3 just by replacing that 10 with 3. It doesn't really matter. Now here, you would see that there are several different columns that are being represented here. But there are these ellipses, which mean that some of the columns are not being shown because there's too many columns to show. And one thing we can do for that is specify the columns that we want to see, namely the ones that we have concerns about. And the way that we can locate a given column and represent that instead of the entire data set is using this LOC function, which is short for locate. Basically, this lock function will locate anything that you want it to within the data. So if you want to locate rows where a given cell has a certain value, you could do that. You could locate certain columns, you can locate certain rows, stuff like that. Here, what we're doing is locating these columns here. And then we're just using a head function. And these were all the ones that we were concerned about earlier. So as we look through this, we see construction year has a decimal, which doesn't make sense. Price, you might expect price to be an integer type or a floats type. But it was loaded in as an object, and this is why. It has a $ and a comma. If it has anything other than numbers, other than a period, then pandas will read it as an object instead of an integer or a float. So that $ and that comma makes pandas think that it's supposed to be an object. What we can do and what we'll do later is cut the $ and cut the commas so that it can be converted into the proper data type, which is an integer. Right. Minimum nights, that's a strange one. You wouldn't expect there to be a fraction of a night. Number of reviews, again, there's nothing in this decimal place, so that doesn't make sense. The last review was loaded in as an object whenever it should have been a date, and a couple of things like that. So the first thing I want to do is focus on all the float data that should be integer data. And the ones I can immediately convert are construction year, minimum nights, number of reviews, review rate number, calculated host listings count, and availability 365. We can convert these immediately because there's nothing in these columns or any of the cells that suggest that it should be an object, right? They have the single decimal place and everything is a number, so it can convert from floats to integer very easily. So all we have to do is specify all the columns that we want, and then say data frame, look for these columns up here, and convert them into an integer type. And once we do that, it'll run, and it runs successfully. Now, we can't convert price or service fee directly because of those because of the dollar signs and the commas. So what we do there instead is replace them. So here, under this replace string, I say, hey, look for this dollar sign. And now I want you to replace it with nothing. And similarly, I want you to look for a comma and replace it with nothing. And it's doing that for both columns, price and service fee, in the data frame. And once we do that, it'll still be an object data type because we haven't converted it. But because we got rid of the things that made it think that it was a object, it can be converted into an integer. So now I can say, look at the price, look at the service fee, and convert it to an integer. That will run. And now we're going to check our data types again to see if what we've done has been executed successfully. And that can be done using this info command again. And once we do that, let's look at construction year again. Construction year is now an integer, as is price, service fee, minimum nights, and number of reviews. So those executed properly. And those were all the ones that we were concerned about immediately. So that is all fine and good now. And now we've cleaned all the ones that we were directly concerned with, but you might want to look at some that you weren't concerned about to see if you missed something. So like, you might look at these data types and think, oh yeah, those make enough sense. But once you actually see the data, you might find that something does not make sense. So I'll show you an example here. So house rules make sense, room type makes sense, this makes enough sense, but as we go, there is one that's a little bit strange. I'm not sure if I can show it here yet, because this is a little bit of a strange setup, but if you're able to go look at instant bookable, that's usually going to be a true false instead of a 0, 1. And so what we want to do is convert those to zeros and ones, because whenever we get into machine learning and correlation analysis and things like that, where we're really getting into the data and figuring out what it means, it'll work a lot better with binary values than it will with text, right? So if you have true, false, it's better to convert it to zeros and ones because it's just easier for Python to read it that way. So here, one thing I can do is check to see if it is a truly true, false instance. And it was, so what I did is use this getDummies function. What getDummies does is pretty much convert the values of a categorical variable, which is basically just looking at your data, providing a category for it to be in. Like in this case, the category would be true, the category would be false. In this getDummies, it just converts that true, false into binary variables, so zeros and ones. So let me run these. And once we check our work by loading it, by specifying we only want that one column we were concerned about, and using a head function, we'll see that it is in fact zeros and ones, so that has worked. Now, one thing about this data set is It's a little bit,
Max.
yeah, what's up?
Hi, Max. This is Shohit. Can you hear me?
Yes, I can hear you.
Oh, okay. Just to interrupt you. Just I'm just reviewing this Panda after maybe 1.5 years. So just to see that you are just replacing true and false with 0 and 1, and what an NaN is giving by 0 or 1, what it takes, 0 or 1 in the data set when the values are NaN, not a number. So it takes 0,
Yeah.
right? It should take.
I think that if it has NaN, it just remains as NaN, but I'll check that later on. I'm not sure about that.
Yeah, just you can see the data frame, what it looks like after updating it. Now you can see it.
Mhm. Yeah, actually, let me add in a code block so I can look at that information for you. So, right, so we converted instant bookable. All right, instant bookable. Yeah, it does appear to have converted the NaNs to zeros, possibly to ones, but I doubt it, because it has the same number of non-nulls as the number of entries.
Okay, thank you, Max. Go ahead.
Max, I have a question for you.
Yeah, what's up?
Can you go to the data frame in the 8 long, the title long? Can you go up, please?
Yeah.
Little, yeah.
Tell me where.
Yeah, I have seen, yeah, it is in the column long, lat, lat and
Yeah.
long. Yeah, there is a negative. What does it mean?
Yeah, so that's latitude and longitude. So,
Okay. Yeah, I got you then.
Mhm.
Yeah, thank you.
Yeah, no problem. Right. Now, this data set has pretty wonky column names. Some of them are all in uppercase, some of them have spaces, some of them don't. It just gets a little bit messy to type after a while because you have to remember the exact case that everything is in. So what we can do to make it a little easier to work with is rename our columns. I prefer to rename them to just all lowercase and using these underscores in place of spaces, just because that makes it a little bit easier to read and everything. But you can use whatever naming convention you like. So here all I'm doing is saying I want to rename this and storing it as a new data frame. Once I do that and do df info, you'll see that everything is now lowercase and in a decent naming convention. Another thing you can do, especially if you're doing a lot of work with text data, is lowercase all of your text data. The reason you want to do that is that Python is really bad at understanding what words are, basically. Like if you have one word that's uppercase and one word that's lowercase, it won't recognize those are the same word. It just thinks, oh, this string of text has a capital and this one doesn't, so they must be different. So what you have to do is make it all lowercase or all uppercase. Either one of those two doesn't really matter, so that Python is able to recognize that the words that are the same actually are the same, if that makes sense. So here I'm just specifying all the columns that have text in them and storing that as a variable, text. And now here, I basically say, I want to look at my data frame, and I want to look at all the columns that are in that text variable, and I want to make those all lowercase.
Max, can I add something here? Basically, in the text, we are making a list. Is basically the iterable. So whenever you want to use the lambda function, so it has to be an iterable. So instead of text, we can say that is basically a list. we can use the tuple, but we're using it as a list. So whenever we're applying the lambda function, and lambda is basically one line function that you are using to change it to the lowercase. So I think list is in here. We're using it, right?
Well, I'm sure that there are other ways to do it, but this does work, at least for this data set.
Okay, thanks.
Yeah. Here what we can do is check one of our categorical variables to see if there are misspellings or categories that can be brought together. Because lowercase isn't going to find like human errors in spelling. So if you have a categorical variable that you need to know like the exact categories that you have, then what you can do is use this unique function, and it'll list all of the possible values that exist in the data set for that column. So here in host identity verified, you had unconfirmed, verified, and not a number, or null, basically. And those all make sense. It doesn't look like there are any misspellings, so we don't have to correct anything. But let's say that there were a few instances where unconfirmed wasn't spelled correctly. It would provide that in the unique function output, and you would be able to look at that and replace all the values that are misspelled with the correct spelling. And that just makes your analysis more accurate as you go forward.
Yeah, Max, one question.
Mm-hmm.
If we have a categorical data like in a Likert scale, like very likely, likely, neutral, unlikely, like that. So it is also addressed in this unique feature column output.
Yeah, all that unique really does is find all the possible entries, or all the entries that exist, all the unique ones within a given column.
Okay.
So it's really helpful for checking to make sure that all of your categories are consistent and that there aren't any data entry errors, basically.
Thank you.
And now, one thing about data that's annoying is that often due to collection errors, you find that there are repeated rows in the data set. And that can become an issue because that can affect your analysis in a few different ways, really. Because say like you have two identical texts that you want to classify into a category, now it's getting overtrained with that text, which basically means, hey, it's seeing this text 2 times and it's being trained on this text 2 times, where it should only be trained once. And that can change how accurate your classification is. So in that instance, you'd want to remove the duplicate. Likewise, if you're working with numbers and you're wanting to provide an average and you have a lot of duplicates, but you're only supposed to have the one entry for it, that can affect your average, which can affect so many other things as you go forward. So deleting duplicates is an important step. It's easy, but it's something that's easy to forget too, but you need to do it. So basically all you have to do for that is say, hey, I want to take my data frame and drop all the duplicates. And now I'm just going to store it as a data frame again. And once we check to make sure that that's ran, we will see that it has gone from 102,598 rows to 102,057 rows. So it's dropped quite a bit, about 500. You could see, especially if it's a small data set, if you have a lot of duplicates, that would affect your analysis by quite a bit. Now, Assuming that you know what your analysis question is, filtering your data down to what you actually need is a good step because this will cut down your file size. And it just makes it easier for other people to work with it because then they're not looking at it and saying, wait, what is this column? Why aren't we using that? If you limit it to what you need, it saves on your memory space and it just makes your data set easier to understand. So all you really need to do is say, hey, I want to take my data set and I want to have it only with these columns and store it as a new data set. One thing is that anytime you're finishing one of these major steps, save it as a new data frame. Do not assume that what you are doing is perfect, basically. Because if you ran through the entire analysis, ran through the entire cleaning process on one data set, and you look at it again and you see, oh, well, I probably made a mistake in the, I don't know, in the duplicate space. Now you can't go back to the data set before you dropped duplicates and do it. You have to run all of your code again. Right? And that just takes some time. So saving it as you go along as new versions of the file is helpful for both you and your team because it allows you to go back and correct any mistakes that you might have made. Or even just try a new approach with the analysis. Right. So here I'm saving a new version of the data frame. This is a code block that you would use if you wanted to filter it down to certain rows. In this case, the data is pretty well concentrated in New York, so there's really not a whole lot of reason to filter it by region or something like that. So we're not going to filter out any irrelevant rows, but what we can do is reduce our column count to what we actually need. But if you wanted to filter down the rows, you can use that locate function again and say, hey, I only want it if this given column has this value. You can also say, like, if it doesn't have this value, if it's greater than or less than that value. And you can also combine those statements by using parentheses around 1 and using an operator before specifying the next one. And there are two main operators there. There's an AND, which is an ampersand as you might expect, and there's also an OR. So you would say, hey, I want the data set if this is true or if this is true. And if you want to specify that, you can use a vertical bar like that. And these can get longer than 2, but for now, just the basics. 2 is probably fine for us. Right. So we're going to filter down to the relevant rows. And now this is called address troublesome data. What we're going to focus on here primarily are outliers, aka numeric values that are significantly further away from the group than any others. So like, if you're thinking about this in terms of like income or something, think of like your typical income of an American, and then suddenly you have Jeff Bezos, right? He's way further away than everybody else is. So if you try to incorporate him and other people similar to him and say, I want to get the average income of people in the United States, then they would pull the value further and higher. So eliminating them could be a good step. There are reasons why not to, but we're not going to get too far into that. We're just going to talk about how to do it and a tiny bit about when. So again, to make sure that we have saved our work all the way through, that we can refer back to our old sets, we're going to create a new data frame specifically for addressing this troublesome data. Right. A good way to visually check if you have outliers is to create a box plot. And this is where matplotlib comes in. Again, matplotlib is a visualization library, and you can use it to make the plot itself, to add different labels to your data. You can change the colors, all sorts of different things to make your visualizations a bit better. So here, I'm using it PLT to stand for matplotlib to make the title, the label for the x-axis, the label for the y-axis, and I'm also rotating these x labels to 45 degrees because if they were just straight across, they would be overlapping each other. And you do need matplotlib or a similar program to do that. So mainly those visualization libraries are helpful for creating complex visualizations that base Python or pandas can't do, and to make your visualizations look better. But here, we're just creating a very simple box plot by saying, hey, look at my data set, create a box plot for all of the numerical variables. And now specify the labels and the ticks and everything, and we will get these box plots. Typically, what you look for outliers are things that fall well above or below these T's at the end of your bars. So there really aren't anything that's of concern in construction year, price, or service fee, but in calculated host listings count, you see that the range of your typical values is very small, but there are quite a few that are above that. And now, since these are all at the same scale, it's a little bit hard to see what this actually means. So let's plot it separately just to see what that looks like. And you can specify which column you want to do by modifying your box plot and specify your column or columns. And once we run this, we'll get this output. Again, very small expected range and quite a few that are above. So there are quite a few potential outliers here, but it's important to think about what this data actually is to say whether or not these outliers are of any concern to us. So let's say that like we wanted to provide like, what would be a good example here? So like, if you're looking at like house prices or something, and as you go along through your data set, you see pretty typical house prices in the range that you would expect, but then suddenly you see several that are like 4 or 5 billion. That's probably a user entry error, or the data collection process went wrong somewhere. Those are safe to eliminate. But if you see something that you think could be valid, you should probably include it. Because even data that is a little bit outside of the rest of the range of the data, but is still valid, is important to your analysis. And this is a good example of that. So here we see like, yeah, most of them are really small, and we can actually see that better in this histogram. Like, the most common listing counts was probably between like 0 and 40. And then there's some all the way here. But as we look at the scale of this, we see that the range, while it looks big because this is small, the expected range, these values don't differ all that much, and it makes sense why they could be this high. So calculated host listings counts as like the number of people that have been in this given Airbnb. It would make sense that there are a lot of new people that have very few listings, but that some of your older ones that have been more successful over time would have significantly more visits. Now, if we saw that somebody had like 5,000 visits or something, that would probably be a bit worrisome. But here, all the values are relatively close to each other. So I'm willing to say that this is probably realistic and accurate data, so I'm not going to remove anything here. Now, if you wanted to remove it, there are a few different ways to do that. I provided one way in here, which basically looks at the interquartile range and finds the lower and upper bounds and removes anything that falls above the ceiling or below the floor. And that is something definitely to look into if you are concerned about any data that you're working with. And there are a few other ways to address outliers, but this is a fairly easy to understand way. So if you want to look into that, I would recommend researching the interquartile range and then going through this code to see how it works. But we're going to move on and talk about how we handle null values, aka missing data. A null is basically whenever a cell does not have any value inside of it. And the way that you address these nulls is different depending on if it is numeric or categorical. And that makes sense, right? Because in one you can do math with it and the other you can't. And I'll explain a little bit more about how to address each of those. But first, there are two main ways of handling these null values. The first is to do something called imputation. Imputation is basically just replacing your null value with another value. And that value is usually representative of your data in some way. And then removal is just getting rid of that entire cell, getting rid of that entire row or that entire column. And there are times and places for doing either of these. Usually, if there is an important variable that has some missing values, aka its importance to your analysis, then you should try to impute things. And you should also try to impute if there is a row that has unique insights but doesn't have complete information. So say like you're looking at these Airbnb listings and there are only a few that exist in this one borough. But some of those in the borough do not have any information about the price somehow. It would be a good idea for you to put that in there so that you can impute some data into that price value so that you can have a more accurate analysis and that that particular borough is represented in your data. Because you don't want to take that out because that would just misconstrue your data and not represent that borough. So imputation helps to solve that problem. Now, if there are a ton of missing values in a column, then you can probably remove it. Same thing if you have a row that isn't all that important to your analysis and it has some nulls, you can probably just remove that. So to talk a little bit about how you handle both of the data types, numeric and categorical, I'm going to do some examples. This will not clean the entire data set, but it will clean a couple of the columns just so that you get a rough idea of how this works. So first I'm going to start working with a new data set. Again, save your work as you go. It makes it easier to reference things later and to correct any mistakes you might make along the way. So now I'm going to use this info command again to find out how many nulls we have in any given column. So here in this index, you see that we have 102,058 entries. And then we have this thing called the non-null count. This counts all of the cells in that particular column that has a value, right? So they're not null. So if we see that this has the same number of entries as number of rows that are not null, that means there are no null values there and we don't have to be concerned with imputation or removing anything. Whereas if we see something like this, where the value is smaller, that means that we do have some null values and we want to correct that if at all possible. And again, the way that you do this is a bit different depending on your data. So if you have a numeric value, aka a quantitative variable, you should probably aim to use either the mean or the median to impute in its place. Now, whether you use the mean or the median depends on the skew of that given column. And I'll show you what that looks like here. So in this price column, I'm making a histogram to see what the distribution is. And we see that it's pretty much even all the way through. If it's even all the way through or it's normally distributed, then the mean is probably fine for your imputation. However, if it has a skew, aka it's heavier to the left or to the right, then the median would be better. So if the mean is okay to use, what we're going to do is basically take our column and use this fill NA function, which just says fill anything that's a null. And we're going to specify, I want to fill those null values with the price and the mean of that price. And then we're going to round it down to just an integer, just for simplicity's sake. And once we do that, and we check, it should say that price has 102,058, which is the same number as the entries, so that has worked. And that's one way that you would address numeric variables and their imputation. If you have a categorical one where you really can't or shouldn't anyway work with the mean or the median, what you can use instead is the mode, aka the most common value. So here, what I can do is look at cancellation policy, which I know is categorical, and say, I want you to count every instance of all the unique types. So cancellation policy has 4 unique types at the moment: moderate, strict, flexible, and null. And what this does is count every instance of each of those categories. So here we see the mode, the most common is moderate. So what we can do now is use that fill null function and put in that most common value. And if we run that and check our data frame again, we will see that cancellation policy now has no null values. Now, what's important to note about these two methods that I just shown you is that they are very basic, right? These are usually fine if you have a small number of null values to correct. But if you have a large number, then it's probably going to make your data more inaccurate. So There are two ways that I'll talk to you about just briefly to handle these. If you are working with quantitative variables and you have a lot of nulls that you need to impute, then there is, in the stats models package, an imputation method called mice. Mice will look at surrounding variables and predict the value of the quantitative variable and take that prediction and impute it. It's not perfect, but it's probably the best thing that we have right now. And there are other ways, but that's the one that I'm most familiar with right now. And for categorical variables, you will use a classification method instead. And one of those is called k-means clustering, which does a somewhat similar thing to the mice package. And what that does is look at the surrounding variables, group the data into different clusters, aka categories, and then use those clusters to assign a category to the data that doesn't already have a category. So say like all of the residential buildings in a given area cost like, I don't know, $50,000 or something along those lines. Yeah. I don't know, I just made up a number. I don't care. But if we took that, then k-means clustering would be able to look at that number and say, hey, this correlates well to this category. So if I see that number again, I'm going to assign that category to that property. And there are other classification methods. In fact, there are a lot of classification methods. But that's a pretty basic one that works pretty well overall. Now, I know we went through quite a bit there, but that is pretty much the entire data cleaning process. So if we go all the way back up to the top and just review what we've done so far, we made sure that all of our columns had the correct data types. We got rid of any duplicated data. We filtered down to only the data that we want, whether that be rows, columns, or both. We addressed any outliers that we might have found. And we also handled missing data if it existed via imputation, which again differs depending on if it's a number or a category. But that's the general process. And one thing to note about it before we go is that this process is not nearly as linear as I've made it out to be. Oftentimes you'll get through one of these steps and you'll notice, wait a minute, I made a mistake somewhere along the way because this thing doesn't make sense. So you have to go back, redo your work, and then see if it got fixed at the end of that. And you might even have to go back to your cleaning process in your analysis phase, because pretty much anything for data analytics and data science is iterative. Basically, you're always going back to what you did before and improving it in some way, and then going back to what you were doing. And you basically just keep iterating until you have something that you're happy with at the end. It's very rare that you do something just step by step by step and have it be good at the end. But that is pretty much the data cleaning process in a nutshell. I didn't get to get into text mining because we covered a lot already. But if anybody's interested in how to process text data, then I can create a recording on that. Because text data is a little bit weird. You basically have to count the number of words and then see how that fits into things. But yeah, this is just a general overview for data cleaning that applies to most data sets that you work with. All right, I know that was really long and really dense, but this has been recorded. and I will be putting this on our YouTube page and it will be on our websites from there. But before I head off, does anybody have questions about anything that we've done or about the club or anything like that? All right. Well,
Yeah, Max, it's a very useful sessions. I learned a lot about the data cleansing because previously I used to do the Excel to, identify the outliers, and those were not in line with our requirement objectives. But these tools is really helping. And thank you for letting us know about this
Yeah.
through these sessions. And yeah, thank you very much, Max.
Yeah, absolutely no problem. And yeah, Excel can do some of this, but not all
Yeah.
of it.
Yeah, and if the
One
data
thing-
is too long and like 10,000 or 15,000, it's quite, tedious and
Yes, and regarding Excel, one thing that I would always bring up as to like why we use Python and other programming languages, even R, is that Excel has a really difficult time working with large data sets.
yeah.
It's too dense of a program and it just has trouble if you have data that's of a certain size. But Python does not have that issue, and R does to an extent, but it's still better than Excel. But Python is better than R.
Yeah, you're right. It is the elder bird.
I
Yeah.
mean, R is still a great program if you know it.
Yeah.
But the reason why we're doing everything in Python is that if you look at job listings for data analysts and data science, you usually see Python or R.
Yeah, you're right. Yeah.
So just focusing on what people might benefit the most from,
Mm-hmm. Yeah, I got you.
But yeah, any other questions before we sign off? I know it's a little past 5, but that's probably okay, right?
Hmm.
Thank you so much, Max.
Yeah, no problem. And if y'all have any questions, you're fine to email me or to comment on the YouTube upload or anything like that. Yeah, I'm always happy to answer or to, yeah.
Yeah. Max, after this, if anybody doesn't have questions after this session, we'll just have a small talk around 1 minute. Yeah. Regarding like I have some PhD student in my department. They're around like 40 to 50 people, but half of them don't know about these analysis tools and Python, all these, they don't have basic knowledge, same like me, but it's very important to have those skills while you are studying the PhD. So I would like to have some kind of similar kind of in-persons or Zoom meeting with our colleague peers. That will be very, very useful. So I'll be having a talk later on. We'll plan how we can go. Yeah. So that is
Yeah,
very,
well,
very, that would be very, very useful.
well, if you want to share this with any PhD or graduate or even undergraduate students,
Yes.
you can, because this club is open to any classification of student.
Yeah, you're right. Yeah. Yeah, I will coordinate with you to make a plan for the event in future. So that is really very, very useful. So it will be useful for our especially the PhD students who are extensively doing the research work right now. And we have a lot of students who doesn't have much idea about the programming languages. That is very, very important for them. Yeah. Thank you, Max.
Yeah, no problem. Yeah,
Have
you
a
can
good
email
weekend.
about that. We can get some new people in maybe.
Yes.
But yeah, if nobody else has some questions, then thank you all for coming. I'm glad to see some people show up for this. I know it was a little long and a little dense, but we do only have an hour for these things.
Yeah.
But I tried to give you an overview of everything, and if you
Mhm.
want to go deeper into anything or ask questions, feel free to email me or ask on the YouTube page or anything like that, as I said. All right. Well, again, thank you all for coming. I'm going to check the comment one last time because I do see something in there. Yes. Thank you.
It was
Rachel.
just recording. Yeah.
Mhm.
But yeah, again, I'll get this uploaded. Thank you all for coming.
Yeah,
And
thank
I hope
you.
to see you at the next one in 2 weeks, if I remember correctly. It's either 2 or
Yeah.
3.
Yes.
Thank
All right.
you. Thank you. Thank you, Max. That was a nice session.
Take care, everyone.
Thank you. Have a nice weekend, Max. Enjoy. That's really very useful program.